Yesterday we did solving trig equations. We're continuing with that, but upping the difficulty level. The first four are similar to what you did in last night's assignment. You're looking for when is the cosine equal to 1/2, and this one is actually wrong. Cosine is your x value, so that would be right in here. That's equivalent to pi over 3. The other place where your cosine is 1/2 is 5 pi over 3. Moving on, the sine of theta equals negative radical 2 over 2. That would be down here in quadrant 3 and 4. We're looking at our y value to be negative radical 2 over 2. That is 5 pi over 4. And over here, 7 pi over 4. When is the tangent equal to negative 1? That would be here in quadrant 1, quadrant 2 and quadrant 4. It's equal to 1 when your x's and y's are the same, and we need it to be negative. So that would be here at 3 pi over 4, or down here, which would be 7 pi over 4. Last one, cosecant of theta equals 2. That means we're looking for when is the sine of theta equal to 1/2. That would be here and over here. So pi over 6 and 5 pi over 6. Alright, moving along, and I kind of have this set up. So I want you to think about this trig equation here, similar to how you would solve a linear equation back in Algebra 1. You would bring your x's over to one side, you would move your constant over to the other, and then finally you would divide by that coefficient. We can do that same thing even when it's a trig function. In other words, I'm going to subtract 2 cosine of x, and I'm going to add 1. Exactly what I did over there, only difference is I have a cosine of x and not just x. Again, we're going to go and divide by 4. We end up with cosine of x is equal to 1/2, which we just did up here. And we got x was equal to pi over 3 and 5 pi over 3. Here's where we're going to also pull in some technology. So I went ahead and graphed for us both of these equations. So we have graphed, the blue one is the 2 cosine of x plus 1, the red, and I guess they're different colors. This lower one right here is 2 cosine of x plus 1. This one up here is 6 cosine of x plus 1. Remember, when you're solving a system, you're looking for where their points of intersection are, which in this case would be here and here. And certainly that continues, but for now we're just writing our solutions in between 0 and 2 pi. Let's check that out on our calculator. I'm going to pause for a moment and get both of those typed in for us. So just showing you on your own graphing calculator, I went up to y equals, I typed in the 2 functions, I went and changed my window from -1 to, and right here I literally typed in 3 pi and then it changed it to a decimal. And in terms of scale, I decided to do it by pi over 4, and again it changed it to a decimal. Finally, when you look at your graph, you can see there are several points of intersection, and we can go and find that. We're going to go into Calc, and we can go to their points of intersection. And there gives me one of those intersections is 4.71, which should be equivalent to that 5 pi over 3. Let's make sure it is. We've got 5 pi divided by 3, and that is not checking out. I'm back and found my mistake. It was when I typed in my equation. The first one should have been 6 cosine x minus 1. Went and looked at my graph. I used my second trace button. I did end up with equivalent of 5 pi over 3. Alright, moving on to the next one. Number 6, again, going back to Algebra 1, this is quadratic. I can solve this one by the square root method. I divide by 2, I go and take the square root. Notice you end up with 2 solutions. Same thing here then. I'm going to divide by 2. When I go and take the square root, I end up with plus or minus 1 over radical 2. When I go and simplify each one of those, I get radical 2 over 2 and negative radical 2 over 2. So if you think about on the unit circle, if I'm looking for when is the sign equal to radical 2 over 2 or negative radical 2 over 2, that's at 4 different spots. Take a look at that intersection, you can see that as well. There's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Let's fit that in here. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Alright, we're going to continue to up the difficulty level just a few more times. Number 7, we're looking for when is the sign of 2 theta, in this case equal to negative radical 3 over 2. We're going to put down 2 theta. We're looking for is when is it equal to negative radical 3 over 2. So if you go back to your unit circle, we're looking for when is the sign negative radical 3 over 2. That's true at 4 pi over 3 and 5 pi over 3. So let's list those down. We've got 4 pi over 3 and 2 theta equals, was 5 pi over 3. Notice we don't have just a theta, we have a 2 theta, so we need to go get rid of that 2. We can divide by 2, which is the same thing as multiplying by 1/2. We end up with theta equals, when I reduce this, it looks as though I get 2 pi over 3, and over here I get 5 pi over 6. Alright, looking at graph number 7, I'm noticing this should have been this graph is incorrect, so let's make our life a little bit easier. Let's just change this so this would be roughly down in here. And again, we're not looking for perfection anyway, we're just looking to make that, again, graphical connection for you. If you see you've got 1 point right here, this point right here, 2 pi over 3 is greater than pi over 2. When I plug that into my calculator, I got that point to be 2.09. I got this point here to be 2.62. And then if you notice, if we're listing all the way up to 2 pi, I would have to go and find these points of intersection right there as well. Alright, moving on to the next one. I've given you now one that is not a common one on your unit circle. Looks like our graph is okay on this one. Looks like we've got 1, 2, and really just 2 solutions when we're focusing on a domain between 0 and pi. We can't do this one in our head, so we are doing sine inverse of 0.654 is equal to that 1/2 x. Let's go ahead, we're doing inverse sine of 0.654. We end up with 0.7128, and we're going to turn around and multiply that by 2, and we end up with 1.4257. Got to do a little bit of thought process because we can see there's one other solution. Let's go think about on our unit circle. We're looking for when is the sign positive. Well, one of those cases we got was 0.7128. Well, this is 3.14. This is 1.7. That would be roughly in here. When else is that sign positive? Right here. So I go all the way to pi and I go back that amount. So my other solution would be 1/2 x equals pi minus that 0.7128. Let's go ahead and do that on our calculator. 2. Well, that's 3.14 divided by 2 is about 1.7. We can see we're a little bit shy on that one. 3 pi over 2 would be roughly about 9 divided by 2, which is around 4.5, and that one looks like it's a little bit over. So again, graphically, our solutions are matching up with our coming up with algebraically. Okay, looking at this last one, I want you to notice what we really have in here is a quadratic. I'm going to show it to you. 2y squared minus y minus 1 equals 0. We've got to go and factor this. This is a 2y and a y, and I believe it's a minus 1 and a plus 1. Let's check it out. This would be negative 2 plus 1, which gives you that negative 1. We're going to set each one of these equal to 0. This one would end up giving us, we subtract the 1 and divide by 2, we get negative 1/2. We're actually going to do the same thing here. The only difference is instead of a y, we have a sign of x. So it might be easier to pretend what we've done is y is equal to the sign of x. That means when we get down here, we're really looking for when is the sign of x equal to negative 1/2, and when is the sign of x equal to 1. Let's start with the positive 1. Let's go picture our unit circle. Our y value is 1 all the way up here. So we've got x is equal to pi over 2. When is the sign equal to negative 1/2? That would be here and here. So we're counting by 6. This would be 6, 6. This moves to 7, 6. So up in here, we've got 7 pi over 6. This would be 12 pi over 6, but we're short of that, and we end up with 11 pi over 6. And again, I'm going to go ahead and show you this one on your calculator as well. Give me just a moment to type it in. Alright, and the last one, I went ahead and typed it in its factored form, which is what we had essentially here, but we replaced the y with the sign. When I go ahead and graph, we can see our graph. And remember, I made it such that each one of those tick marks are pi over 4. So if you look at that first one, that would be pi over 4, that's pi over 2, which is the same thing that we got here. 7 pi over 6 would be a little bit larger than a pi. Well, right there would be my pi, so a little bit larger would be right there. I could always go and hit second calc and go find that 0 if I wanted. Let's go find maybe one of them. I guess let's find this one since we're sitting at that one. And we get 5.759. Hopefully that's equivalent to this 11 pi over 6. Let's go check it